Hello, 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 hello. I'm so happy you're watching this video today. I'm so happy that you are my student. We're going to have a great time together. Today is lesson number 12 in your awesome math book. I'm going to put my name and today's date at the top of the page. My name is Miss Caitlin. What is yours? Miss Caitlin. Oh yeah! Today is October 6th, I think, or October 7th. Oh, October 7th. Oh my gosh. No, yes. Well, you know, this is pandemic quarantine. They say we have no idea what day it is. So I think Miss Caitlin just had a pandemic quarantine moment. I was like October 7th, October 8th, October 6th, I don't know. Anyways, you'll find out what day it is. Okay, we're doing lesson number 12. There are two parts to that lesson. The first part is 3 as a factor in a multiplication problem. Check this out. The numbers you are multiplying together have the name factor. And the answer to a multiplication problem is called the product. So, when the title of your lesson says 3 as a factor, that means you are going to multiply times 3. Now, all of you have 3 times table flashcards, and your homework is to be practicing them all the time. So this front page is going to be very quick for you. All right? I'm not going to work on times 3 with you. You've already been practicing that. I am going to skip down to section 2 and section 3 because I want to do 2B and 2E with you, as well as 3B and 3E with you, which leaves 2A, C, D, F, and 3A, 3C, 3D, and 3F as your homework after this video. Section 1 is your homework, 2ADCF and 3ADCF are your homework after this video. So when I get a glimpse of your math book at any point after this, those should be completed. Now, we don't know when that's going to happen, but we'll get there when we get there, right, chickadees? Okay, so section 2 and section 3, they want you to place the decimal point and the dollar sign for these amounts of money. You see lots of digits in a row. The digits are the single numbers from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the digits. And when you put them together, they make numbers. So these digits are here because these are the prices of things. When you do money, how many times do you go over before you put your decimal point? How many numbers do you count before you put your decimal point? I hope you said 2. Here we go with our handy dandy pencils on 2B. I count over 2. 1, 2, decimal point. And then in front of everything else, I put my dollar sign. All right, skipping down to 2E, I count over 2 digits from the right. Always start small. 1, 2, decimal point, and I go all the way to the front, and I put my dollar sign. It's a large S with 2 lines through it, okay? That should help you to do 2A, C, D, and F. All right, that's your homework. Now skip down to section 3 because they're only doing cents. The directions say all of these amounts are less than $1, okay? Less than $1 are your cents. C-E-N-T-S, the cents, okay? So you're going to count over 1, 2 to place your decimal point. And then in front of that decimal point, after a little space, you're going to put your dollar sign. Okay, here we go. 3B, that's the one in the middle. I go 1, 2, decimal point in front of that. I leave a little space and I do a dollar sign over there. Now 3E looks a little tricky, right? Because there must be 2 digits after the decimal point. Remember, the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the digits. 0 is a digit. Okay, so we're going to count over twice and fill in anything that needs to be filled in. Here we go. 1, 2, decimal point. You see that? There must be 2 digits after the decimal point in money. So, where there isn't anything, we put the digit that means there isn't anything, okay? We're going to put in a big fat 0. Watch Miss Caitlin. And do that on your paper. At 3E, you need to count over twice. 1, 2, place a decimal point and put the digit in the space where there isn't anything. This is the digit that means nothing. Okay, and in front of all that, we need to put our dollar sign, okay? I did 3B and 3E to help you with 3A, C, D, and F. All right? I know that was fast, chickadees, but it's not our first rodeo, okay? Okay. Here we go. Turn the page. Yes? Because we're moving on to geometric shapes. Oh my gosh, we're getting so smart. Okay, look at the top of your page 4. You see all these beautiful shapes, the circle, triangle, square, diamond, kite, trapezoid. That's one of my favorites. I'll teach you another day why that's one of my favorites. I draw a little cartoon in there and do a little story. All right, here you got your oval, your rectangle, your rhombus, your right angle, your hexagon, your pentagon. All right? See all those beautiful things? Let's talk about them. So, this is your introduction to geometric shapes, everybody, on the playing field. Okay, so 2D, 2-dimensional. Is that true? I think so. 2-dimensional. These are not 3-dimensional shapes, okay? These are 2-dimensional shapes, all right? There we go. Section number 4, they want you to count the sides and the vertexes. Oh, fancy word, Miss Caitlin. What's that? I'm about to tell you. If you'd like, at another time, you can turn to the back of your book. Page 374 is in your handbook. That is the glossary of your math book. A glossary is a special kind of dictionary. A dictionary gives definitions of words, the meanings of words. A glossary is a very special dictionary that only has the words that are in your book. Okay, so in your book, in the glossary of your math book, are you going to find the definition of macaroni? No. Okay, in the glossary of your math book, are you going to find the definition of marine? No. Although we know that marine mammals are sea mammals, so it has to do something about the ocean, right? Meow, 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 meow. Okay, so the glossary of your math book is going to define different math terms. So on page 374, they have the definition of side and the definition of vertex to help you count the right thing. Okay, so la-da-dee, la-da-da. This is the lesson part of your lesson. And then you're going to do all the work because you're an awesome scholar. Here we go. A side is one of the lines. One line that makes a plane shape. Now, it's not P-L-A-I-N like plain without decoration shape. It means like on this plane, okay? P-L-A-N-E, all right? A vertex, fancy word. Fancy word is a point. A point where two or more sides meet, okay? That is the M-E-E-T, not the M-E-A-T. Yum, yum, carnivore. Okay, so they want you to count the sides. A side is one line that makes up these geometric shapes, and a vertex is a point where two or more lines meet. Okay, so in those beautiful pictures, right? You see all these black dots? These are the vertex. Why are you? Okay. These are the vertexes. These black dots are the points where the lines are meeting. And you can see in the circle, there's no vertex. You can see in the oval, there's no vertex, okay? But in the rectangle, the trapezoid, the rhombus, the kite, the diamond, the pentagon, the hexagon, the triangle, the square, and the right angle. Well, I didn't put one there. Those all have vertexes, okay? So when they want you to count the side, that means that they want you to count the line. You see that? Okay, the lines are the sides. And when they want you to count the vertexes, see these points that I'm making, these dots? It means they want you to count these dots. 1, 2, 3, 4. All right, so here we go. Section 4, the triangle. How many sides does a triangle have? 1, 2, 3. And how many vertexes does this triangle have? 1, 2, 3. Okay? That's how you do section 4. Count the lines. We'll count the sides, one line that makes a plane shape, and count the vertexes, or the points where two or more lines meet, those black dots, okay? That's how you do section number 4. Let's skip to section number 5, because we want to cut or divide or break these plane shapes in half perfectly. Okay, so the way to cut or break a plane shape or divide a plane shape. When I say divide, I like to say break, because fractions are division related. And when you have a fracture, you've broken something. Okay, so that's why I say all those words together. I'm just preparing you for later on. Oh, 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 there she goes. I flip my hair back and forth. I flip my hair back and forth. Okay, math time. Here we go. We are dividing, cutting these plane shapes perfectly in half. The best way to do that for a plane shape that has 4 sides is to choose opposite vertexes or opposite points. You see how Miss Caitlin put a dot here and a dot there? I'm marking the vertexes or points on that rectangle. A rectangle is a parallelogram with 4 right angles and 2 parallel sides that will never meet. Okay, so the top and the bottom are never going to touch. And the left and the right are never going to touch. There are 4 right angles. Right angles look like this. Cha-cha, boo-cha-cha, boo-cha-cha, boo-cha-cha. And 4 sides. All right, so the best way to divide this parallelogram perfectly in half is to do a top vertex and an opposite bottom vertex and make a line between the two. Booyah, booyah. That's the best way to do it, okay? Because otherwise you have to measure the top line and measure the bottom line and make sure that your ruler is in the perfectly right place and then make a dot in the middle of it and then connect the top and the bottom. Right? Too much work. Just choose a top vertex and an opposite bottom vertex and make them meet. Let's do it with the square, right? You see a square down there? A top vertex and a bottom opposite vertex. I take my ruler. You must use a ruler. I'm going to say it again. You must use a ruler. I'm going to say it again. Once for the Father, once for the Son, and once for the Holy Spirit. You must use a ruler. So if you didn't use a ruler with the rectangle, please erase the line, go get a ruler, come back, use the ruler. I can tell that a ruler wasn't used. You're gonna have to do it again. Okay? Thank you. All right, here we go. Top, bottom, opposite vertex, ruler, connected, perfectly divided, boom, done. Okay, now a circle is different. A circle has no vertexes. There are no vertexes on the circle. And every single point on the circumference of the circle is equal distant from the center. With the oval, right, you see that? Not every single part is equal distant from the center. Like this side is 2 inches away from the center, but this part is 3.5 inches away from the center. Okay, you see that? On a circle, it's a special geometric shape where every single part on the outside is the same distance from the center. Okay, now Miss Caitlin's not a robot. I didn't draw a perfect one. I don't know if that's the dead center, but I'm going to take my ruler. Extreme close-up! I'm going to take my ruler and draw a line from top to bottom, doing my best to divide this circle, break this circle in half, which is a fraction. Okay? That looks pretty good. Use a ruler. Thank you. Okay, so we have done section 5 together. We have done section 6 together. I need you to count the sides and vertexes of the shapes in section 4. That's your work. 1, 2, 3, 1, 2, 3. Right. Okay. Section 7, they give you a bunch of different shapes, and they want you to circle the shapes that have right angles. Now, here's a trick. If you do it, awesome. If you don't, okay. But this is going to help you get it right. All right? Those who are faithful and obeying in the small things are going to be faithful and obeying in the big things. That's what the Lord says. And his word is truth. Okay, here we go. Now, if you use a 3x5 card, your 3x5 card is a rectangle. The rectangle has 1, 2, 3, 4 sides and 1, 2, 3, 4 vertexes, the point where 2 sides meet. It is a special parallelogram. Parallel means never touching, okay? The top and the bottom are parallel, they will never meet, and the left and the right are parallel, they will never meet. These two sides are the same distance and the length, and these two sides are the same length, but this and this are not the same. Okay, so those are the defining points of a rectangle. All right, so your 3x5 card has 1, 2, 3, 4 right angles. A right angle is an angle containing 90 degrees, okay? Perfect 90-degree angle is a right angle. So use your 3x5 card. Put it on the shape and see if the shape has an angle that matches your card. If it doesn't, don't circle it. If it does, circle it. You're looking for shapes that have perfect right angles. So do your best. Use the 3x5 card. Your shape needs to have just one right angle. Not all of the angles have to be 90 degrees, just one of them. Circle the shapes that have at least one right angle. Okay? Do your best. You are awesome. You are great. You are equipped. You are empowered. You are the chosen. Believe it. All right? And the chosen have to get to work. Okay? Because laziness ends in slave labor. But diligent hands will rule. All right? And I've told you everything that has to be homework. I hope you're listening, because I'll know. All right. Anyways, I guess I'm getting kind of serious today. All right, giggle fest at the end, just to lighten things up. Okay? I can't wait to see you again. You are doing so great. Call me if you have any questions. All right. Bye.